Hello, everybody. So, earlier we learned about a famous landmark. What was that famous landmark? That's right, the Statue of Liberty. Good. So now we're going to be learning about another famous landmark that's on the other side of America from the Statue of Liberty. So, Statue of Liberty is on the east side of America, and now we're going to learn about a landmark that is on the west side of America. So, I want you to take a look at this picture here, and I want you to tell me, where is this? Seattle. Good. Good. And do you see a famous landmark in this picture of Seattle? Good. I heard some people say it, the Space Needle. Good. So the Space Needle is a famous landmark in America. So we are going to be learning more about the Space Needle in America. In Seattle is where it's located. So the Space Needle, we're going to first start learning about the physical aspects. Say that with me. Physical aspects. Good. So the physical aspects of the Space Needle is what we're going to be learning about today. Good. So what I want you to do is first think about, so you know how we learned about what the Statue of Liberty is made out of. So what are some of the things the Statue of Liberty is made out of? Yeah, it's simple to say it. Beryllium, good. Copper, yep. So we're going to learn more about what the Space Needle is made out of. So why don't you think with a partner what you think the Space Needle is made out of. Okay, good. So I heard some ideas. So Space Needle is made out of steel. Say that with me. Steel. Good. So it has three steel rods. One here. Say that with me. Steel rods. And then one here. And then one all the way up here. One that covers, that's in the center. Good. So we have the Space Needle that is made of steel. It has these three steel rods. So the top is what we call a saucer. Say that. Saucer. Good. So saucer. And a saucer is this right here. It is a space saucer. That is one thing that it is. It's supposed to resemble like a spaceship that goes up in outer space, and it is like a space ship. So a saucer. And we have the three rods. 1, 2, 3. And so I want you guys to think about how tall it is. Remember how we learned about how tall the Statue of Liberty is? How tall again was the Statue of Liberty? That's right, 305 feet. Good. And we're going to be learning about, so why don't you just start thinking about how tall you think the Space Needle is. Okay? What are some of your guesses? Okay? So I heard some good guesses. Some are really close. So the Space Needle is 605 feet. Sorry, I should have been writing this in here. So we have, this is steel and large steel rods and a space saucer. We already went through that. And then, so the Space Needle is 605 feet tall. So I want you to think about how many U's it would be to make the top, make it from the bottom to the top of the Space Needle. Like, for example, for me, I'm 6 feet tall, so it would take about 101 of me's stacked on top of each other to make the height of the Space Needle. So I want you to think about how many U's it would take. Think it over for a little bit. Okay, good. So I heard some good answers. So there's also another fact that I found on the Seattle Space Needle's website on the computer. And it said that it is as tall as 1,000 320 Milky Way bars. So think about it this way. This amount of Milky Way bars stacked one after another on top of each other to make the height of the Space Needle. And it would take 1,320 of these. Good. So we're going to now move on to how do you get to the top of the Space Needle? I want you to think, what are some ways that you know to get from the bottom to the top of the Space Needle? Stairs, I heard stairs is good, yep. The way to get to the top, that people usually get to the top of the Space Needle, is elevators. Say it with me, elevators. So these elevators will take you from the bottom to the top. And there are 3 elevators in the Space Needle. 3 elevators. So I want you to think about how long, talk with your partner, how long do you think it will take for one elevator to get from the bottom to the top? In terms, I want you to think of it in terms of seconds or minutes. Like, could it be 45 seconds, a minute, 5 minutes? So think about how long you think it would take to get to the elevator. Talk to your partner. All right, good. I heard some good answers here, some really close. So it takes 43 seconds to get to the top, from the bottom to the top of the Space Needle. So that is very fast. 43 seconds is very fast to get to the top. So I want you to also think, what else is fast? What else is fast? And I want you to think of it in terms of the weather. So what is really fast about the weather? Like, is it the clouds? Is it water? What is really fast? So think with your partner and come back to me and think of some things that are fast in the weather. Okay, good. I heard some good ideas. So I want to show you guys a video of some very fast weather, because the Space Needle can withstand 200 miles per hour. Say that with me. 200 miles per hour. So you know, like how you see a car on the freeway, that is going about 60 miles per hour. So if that's going 60 miles per hour, then 200 mile per hour, which we're going to talk about winds, which I heard some of you guess, winds being very fast. So think about how fast 200 mile per hour winds are, and how the Space Needle can withstand 200 mile per hour winds. So these these 200 mile per hour winds the Space Needle can withstand these 200 mile per hour winds. So that's really fast. And I'm going to show you guys a video of what that looks like. Good. There we go. Okay. Alright, so here is a video of some 200 mile per hour winds. So those are some very intense winds, very fast winds. And the Space Needle can withstand, that means it can handle itself without it falling over. It can hold its structure in this fast of winds, in this 200 mile per hour winds. So, and now, alright, and now we're going to learn about how can it withstand that fast of wind speed. So we're going to learn that the foundation, remember how we learned the Statue of Liberty has a foundation at the bottom, and this foundation is very strong. So poured a lot of cement. Say with me, cement. Good. So cement is this type of material that is used to form concrete, like concrete on the ground that you walk on. Concrete. So they filled the foundation with cement and steel rebar. Say with me, steel rebar. So there are these, so we know with the steel, with the very small, tiny rods of steel that are a little bit bigger than this, and they are filled with steel rebar, the foundation is. So it took over 467 cement trucks that are carrying cement to fill the foundation of the Space Needle. So if you look at this picture, here's a picture of a cement truck. With me, cement truck, good. And it's pouring concrete, cement. It's pouring cement into a foundation, okay? So that is why it can withstand such fast wind speeds of 200 miles per hour. Now, we're also going to learn about how much the foundation weighs. So, the foundation weighs, it weighs 5,850 tons. Say it with me, tons. So tons, yes. So tons is a form of weight. So we're going to think about, I want you to think of it like this. I'm going to show you a picture here, and I want you to look at the weight in tons. So what mammal is this? Largest mammal in the world. Heard it, blue whale, good. And what about this small one right here? An elephant, good. So a blue whale, one of those large animals, you've seen this before in the ocean, large mammals, is 200 tons. And an elephant is 5 tons, which is still very big. We all know, we've seen elephants before, right? We've seen how big elephants can be, and that's 5 tons. So this weighs, the foundation of the Space Needle weighs 5,850 tons. That is way more, that is way heavier than a blue whale or an elephant. So it would take, just for fun here, it would take 30 whales, 30 200-pound whales, blue whales, to make the same amount of weight as the Space Needle's foundation. Now say that word again with me, foundation, good. So it also would take 1,170 elephants and all of their weight to make up the amount of weight of that foundation. So now that we know the foundation is very heavy, now we want to learn about the structure. How much does this weigh? So the structure weighs, of the Space Needle, remember the term structure, it weighs 3,700 tons. So I want you to think about, with your partner, just think about in terms of math, how many blue whales and how many elephants would it take to make the same amount of weight for the structure, the 3,700 tons. How many whales and then how many elephants weights would it take to make this, the same weight as the structure of the Space Needle? So talk it over with your partner. Good, some good guesses, some good, so it would take 18.5 whales to make the same weight as these, and it would take 740 elephants to make the same weight, the 3,700 tons of this. So good. So now that we learned more about the physical aspects, sorry, I should have written that a while ago. Physical aspects. Now, what I'd like you to do is talk it over with your partner, talk about something new that you learned about the physical aspects. Go ahead. Okay, and now we're going to be learning about, remember the word that we learned, origins. Say with me, origins. We learned about the origins of the Statue of Liberty. So now I want to talk about the origins of the Space Needle. So I want you to think of some of these questions. Who designed it? So we have origins here. And we'll think about who designed it, who built it, how much did it cost, And I want you to think about the first question. Who do you think designed it? It's a good question. It's not easy to answer. So, a man named Edward E. Carlson was one day sitting in a coffee shop, just sitting in a coffee shop in Seattle. And so here's a picture of him. And he was just one day just sitting in a coffee house, just drinking coffee. And he thought about this tower. And this tower is called the Stuttgart Tower. Now say that with me, the Stuttgart Tower. Good. So here's a picture of the Stuttgart Tower. Now, the Stuttgart Tower is in Germany. So he thought about this, and he wanted one for Seattle. So he started thinking about it. So he started drawing the very first idea of the Space Needle on a little napkin at a coffee shop. And then after that, it got handed over to the architect, the main architect. Everyone say that with me. Architect. Good. And the main architect is named John Graham. And he is the architect of the Space Needle. An architect is, excuse me, an architect is the person who, okay, so an architect here is someone after the artist, here, Edward E. Carlson, then draws up the plans, and then the architect draws up his own plans also, but he focuses more on the structure and how it'll stand up on its own and withstand, you know, like 200 mile per hour winds like we talked about earlier. So he is the architect. So we now know that an architect is someone that will design the structure of the Space Needle or other structures. Good. So he was the one that designed the image of the Space Needle that we see today. Okay. So let me ask you guys, so what happens after you design something? What is the next step? You build it. Good. Yeah, exactly. You build it. So another word for building something is construct. Say that with me. Construct. Good. So we are going to, they then constructed the Space Needle. And the people that did that was a company called Howard S. Construction Company. This company was the ones that actually built or constructed the Space Needle. So, so how much do you think that this Space Needle cost to build, to construct? So think it over and give me some ideas. Yep, I heard some pretty close ideas, but what the actual cost was $4.5 million. Okay. So, $4.5 million is a lot of time. Now, it's a lot of money. So what I want you all to now think about is how much time do you think it took to build the Space Needle, construct the Space Needle? So take a second. Okay, I heard some answers out there. Some people said a few years, some people said a year. It actually was 400 days, so a year and a month, so or a little over a month, so a year and 35 days. So it took 400 days to build. So that's actually pretty fast to build something like this. And it was finished on December of 1961. So, so why was construction so fast? I want you to think about that. Why do you think they built it so fast? And also think about yeah. So think about why was it built and constructed, And why was it built so fast? Think that over with the partner. Okay, so one of the reasons that it was built was because of the World Fair. Now, does anyone say it with me? World Fair. Good. Now, has anyone heard of the World Fair before? Okay, some of you have. Good. So, what is the World Fair? Why don't you just think that over for a second? What do you think the World Fair is? Alright, so the World Fair is a time where many different countries come together and everyone brings their own arts. Say with me, their own arts. So like arts as in like their own painting, sculptures, dances, music. There's tons of different arts that a country can have. And then they also bring their products. Say with me, products. Good. So they bring, so this is now the culture part of, and this is the World's Fair. And many countries are bringing arts and products. Now say that with me, products. So products are like what your country brings to other countries. What are you going to bring? So countries have different products. Like, for example, we have a lot of corn, a lot of wheat here in America. That's one of our products. We have a lot of apples, especially here in Washington. So that's one of our products. So what are some of the products in your home countries? Okay, good. There's a lot of good answers. Cool. So that's really interesting. So you would bring that to the World's Fair and show other countries your products and your arts. So, the Space Needle opened on the very first day of the World's Fair. So, and that day was April 21st, 1962. So on that day, over almost 20,000 people went up the elevators. Remember the word elevators? Good. Went up the elevators to the top of the Space Needle. So almost 20,000 people a day during the World's Fair went up the elevators. So it was a very, very popular place during the World's Fair. And it's still very popular and still very famous today. Also, many celebrities have been to the Space Needle, such as famous guitarist and musician Elvis Presley, and also famous martial artist and fighter Bruce Lee. Some of the famous people that have gone here. Put that back up. And then also there is a Sky City restaurant. Say that with me. Sky City restaurant. So there's a restaurant near 500 feet above the Space Needle. 500 feet up the Space Needle, excuse me. So go 500 feet up, and there's the Sky City restaurant. And has anyone ever seen the show Top Chef? Yeah, so that show, there, for the show Top Chef, everyone went to the Sky City restaurant, and for the season 10 of Top Chef, they had a challenge at the Sky City restaurant. So there is good information about the physical aspects, the origins, and the culture of the Space Needle. Now, what you guys to do is talk to your partner talk about 3 things that you learned that were new, and 1 thing that you learned that you may have already known. So I want you guys to think about that, and then when you guys are done, we're going to have 1 person from each group come up and share.